Randoscience.
Hey guys, this week on Randoscience we interview Matt Jäger, who is a scientific communicator that used to work for the ESA, which is the European version of NASA. He now works for the EMBL, whose mission is to explain life here on Earth. We talk about some really cool things in this episode, about like black holes, primordial black holes, Planet 9, sci-fi, all different kinds of things. So if you want to support our channel, you can do so by liking, subscribing to our YouTube channel, follow us on Instagram, you can donate on Patreon, and you can buy a sticker.
We have some burning questions about the Venus, like phosphine
discovery,
like
Yeah.
whether that's life. Especially since you work for EMBL,
Yeah.
you probably have an interesting perspective on it.
Yeah.
Oh dear, I can only lose. Okay.
But yeah, so we're just curious to think to find out what your thoughts are on it. Like, what do you think? How probable do you think it is that there is life in the clouds of Venus?
That's a very tricky question. I mean, what we have found so far, and with we, I mean my fellow astronomer colleagues, is phosphine, which is just a molecule. So it's not that we found life or bacteria or Amazon women in the forests of Venus. That were the 60s.
Right.
Good old times when we were expecting some jungle-like environment on Venus. We just found a molecule. And the thing is, so if you read the paper, it's actually quite fascinating. They really try to find out where this molecule could come from. So chemical reactions from within the crust of the planet, from basically everything. They test everything and they exclude everything, what comes to their mind. I mean, this is always science.
Yeah.
You think of things and you exclude it. And at the end, you are left with one possibility. And this is anaerobic life as we find it on Earth. So bacteria which don't need oxygen to live.
Right.
This is where on Earth phosphine is created. But it doesn't mean that there is another possibility or that it's really bacteria form or any other life form which is producing it. It's a single hint. But of course, a very exciting hint. It's the first time we found something on Venus. It's been found in the upper atmosphere of Venus. So where it's way more comfortable than the surface. The surface is basically hell.
Yeah.
So 400 degrees. You have high pressure. It's raining acid. It's really, if you imagine hell from the Bible, it's basically the Venus surface.
Yeah, it's brutal. Yeah.
It's really brutal. But if you go up in the high atmosphere, then the temperature drops, the pressure drops. You have no more acid rain. It's basically quite comfortable up there. Well, not for human, but in general, it's compared to the surface, it's very comfortable.
Yeah.
So it could theoretically be possible that some kind of life form existing up there. Why not?
So this may be a dumb question, but if it's in the upper atmosphere, isn't gravity kind of fighting against that to pull it back down into the lower areas of Venus where there's acid rain and all of this?
Well, we have enough animals which kind of swim. So basically fish. They also fight the gravity. They don't fall to the bottom. They keep a level in the ocean or in a lake. And the same can be in a still quite dense atmosphere. I mean, we're still talking about an atmosphere denser than anything on Earth, on the surface of Earth.
Oh,
so
wow.
A very light organism, a bacteria, could basically float up there. Probably some little wings or parachute form, life form. I mean, if you look into science fiction, there are amazing ideas where life could exist in an area like the upper areas of Jupiter or even Venus. Yeah.
Wow.
I think Jupiter is like Dylan's favorite planet.
Yeah, I love Jupiter. It's so cool. I was reading about it recently because I think Hubble recently took that picture where you can see Europa, I think, on the left side, and it just boggles my mind how massive Jupiter is. It's just because I was reading about like the surface layers or like the layers of the atmosphere as you go deeper and deeper. And then when you we think that there's a solid core that's about, I think the article I was reading said 1.5 times the size of the Earth, but 4 times as massive. And that just
dense,
yeah, that just blows my mind. And I just think that Jupiter's like such a beautiful planet. So
It's very beautiful. Yeah, I also think that Saturn is sometimes stealing the show just with the stupid rings. But in the end, Jupiter also has rings, and nobody's
Stupid
talking about
rings.
these rings.
yeah, that's true. Yep.
Yeah.
Yeah. So which one has more moons? Didn't we just discover like 20 more moons around Saturn recently?
I find it a bit tricky. Yes, Saturn by the book has more moons, but what's the definition of a moon? I mean, where do you stop calling it a moon and that's just a piece of rock?
Right. Yeah.
And the problem in astronomy, we don't have a definition for a moon. So we don't say
Really?
down to this size it's a moon. No, there are many definitions missing in astronomy, which is always causing troubles. I mean, we had a couple of years ago the problem with the planet discussion, and out of a sudden Pluto wasn't the planet anymore because we finally decided after hundreds of years to make a definition of what is actually a planet.
Right.
So we are now a bit curious or sensitive in saying, okay, what is a star? What isn't a star? What is the moon? What isn't the moon? Because it will upset a lot of people if you finally make a decision.
Right. Yeah, a lot of people weren't too happy about the whole Pluto thing.
Yeah, it was
makes me think of the Rick and Morty episode. Have you seen Rick and Morty?
Unfortunately, not. No.
Okay. Well, there's an entire episode where
the Plutonian episode.
Basically, the dumbest character. His name's Jerry, and he goes on this like agenda to try and prove that Pluto is a planet.
Yeah, and it's really dumb, but it's a great show. It's really funny.
Yeah.
But if you want to, I know what constitutes a planet, but I know that a lot of people just kind of don't know. Would you mind explaining for anybody that doesn't know, like what the rules are that we came up with?
In the early 2000s, I think it was the early 2000s. Was it even earlier? No, the early 2000s. The International Astronomy Union decided it's about time to make a definition, and so that's basically the organization for all astronomers. And they meet every couple of years to make boring political decisions. At this time, they decided, hey, let's define what a planet is. It was a bit of a back and forth discussion. In the end, they came up with 3 parameters. And the one which kicked out Pluto is basically you have to clean the orbit you're on. So a planet orbits a star, in our case the sun. And if there is enough material still flying around because the planet isn't massive enough, it's no longer a planet. And this is the case for Pluto. So Pluto is so far out that it hasn't cleaned its orbit. There's still so much stuff flying around.
Right.
Another argument is that it has to be massive enough that gravity made it a sphere. So if you look at the asteroids, they all look like potatoes or very weird objects.
Right.
They are definitely planets because they're not massive enough. So gravity didn't make them into a sphere.
Right.
That wouldn't have been a problem for Pluto. I personally don't like the definition, and I'm not alone. There are many astronomers who have conflicts with this. Are you aware of the hypothetical planet 9?
I am. That was actually something I was going to ask you about at some point.
Okay, yeah. So there is the hypothesis that way beyond the orbit of Pluto, that there is a so far undiscovered planet, several times more massive than Earth, which is fine. If you can find it at some point, it would be cool, a new planet. The problem is, despite its mass, it wouldn't be, by our current definition of a planet, be a planet, because it's so far out that the orbit takes so long that it wouldn't have time to have cleared its orbit by now.
Right.
So we would have a huge object at the edge of the solar system, which by all our senses and meanings would be a planet. But according to the definition by the IAU, it wouldn't. And this is where the problem then starts.
So what makes us think that there is a planet 9? What are we observing that's causing us to think that there's possibly one out there on the outer reaches of the solar system?
Basically the same thing which made us discover all the outer planets, slightly perturbations in the orbits. So we always think that the orbit is perfect going around the sun, but in the end it isn't. So there are always tiny perturbations. If you look at the orbit of Earth, we're always going a bit faster and a bit slower because our moon is sometimes dragging it and sometimes it's pushing us. And of course, we're influenced by Jupiter and Saturn. Even though they are very far out, they still have a tiny influence on us. It's very, very tiny, nothing you can really experience in the tides or whatever, but you can measure it. And same is true for the outer planets. So if you now look at Saturn or Uranus, you always see that there are other planets which are influencing the neighboring planets. And now if you look at Uranus and Neptune, you see that there are some things in their orbit which don't really make sense. So it has to be kind of a mass somewhere out there which is causing these perturbations.
Okay.
It could be something super, super tiny and massive, like a super tiny black hole. That is also a possibility. It could be a planet, but it could also be something else. It could be a huge cluster of asteroids or comets. We don't know.
That's wild.
Yeah.
It's completely wild.
Do you like? If it was a primordial black hole, that's kind of what I'm hoping it is, because I just think that would be so cool.
Are you saying
from a scientist
9?
perspective, yes. As a media person, I'm super afraid of it because I already know what the yellow press is making out of it. So we are all doomed and getting eaten by a black hole.
Right. See, I think of it as like, like now there's a black hole within our reach to do research on. Like we can actually now experiment with things around a black hole.
Maybe with probes or something.
With probes, we could send probes out to it. Hopefully,
yeah, that would be possible.
Is there an estimate on how far away we think it is from the sun?
There is, but I don't have the numbers in my head, so I'm not.
Okay.
We were just looking up. We were just kind of.
That's unfair.
Do what? Oh no,
That's
we weren't looking.
You checked the numbers before.
No.
We were looking up other stuff, kind of like I was looking up when New Horizons is going to leave the solar system. And there was kind of some debate on what it means to actually leave the solar system because
of how far the gravitational pull of the sun actually reaches.
Exactly. So I think from Voyager 1 we were able to figure out that the solar winds went out like 80 astronomical units or something like that.
Yeah, but that's not the gravitational pull. I mean, the gravitational pull of the sun is basically infinite.
But there was this orbiting body.
I didn't think about that.
I mean,
yeah.
From a physics perspective, gravitational pull is only approaching zero.
Yeah.
It's never actually zero.
Never actually zero, right.
But we were talking about some orbiting body that was at its closest pass to the sun that we're aware of was 76 atomic units. And then at its furthest path, which we've interpolated, would be like 900 atomic units.
Astronomical units. Sorry, I have to correct you.
You're right. No, you're right. We were just talking about, I do make that mistake too often.
You've gone back and forth a little bit.
I know.
He loves very small things too, so.
Yeah.
That's fine.
I do computational biology and computational neuroscience. So the things that I deal with are on that scale, the atomic scale. So I mix those words.
Right. Understandably so.
I can completely understand this. So the first press release I was writing for the European Molecular Biology Laboratory, whenever I was writing about microscopes, I wrote telescope. The whole press release.
No way.
Yeah, it was kind of embarrassing. Luckily, I found out before I sent it around.
That's good. It's a nice catch, though. I mean, because if you sent that out, people would be like,
something's wrong here.
Yeah. So, I mean, what are your thoughts? What do you like? Do you have an opinion on what you believe constitutes leaving the solar system? Is it at the point that you're not within the solar winds of the sun, or is it at a point to where the is there a threshold for the gravitational pull of the sun to where you're no longer in the solar system?
So, as I said, I'm not a specialist for solar systems, planetary systems in general. But the general consensus is, and I agree with this, is the edge where the solar wind cannot work anymore against the interstellar medium. It's also a convenient thing because we don't actually know for sure how big the solar system is in respect to the Oort cloud, so the leftover which is orbiting somewhere far out from the sun, completely in the darkness. We only can estimate or hypothesis about it. It could be that it goes halfway all to the next solar system, which would be Alpha Centauri, the triple system of Alpha Centauri. Right. But we have no idea. So it doesn't make sense to make it like it goes halfway to Alpha Centauri if we don't know for sure if this is correct. So by what we know at the moment, the solar wind seems to be the best indicator for the edge of the solar system.
That's a good answer. I like that.
That is pretty neat.
Yeah, it's really cool. I was also talking to Andrew about how we recently measured like the gravitational center of the solar system, which I thought was really interesting. Because that's just
You mean the
something we never.
barycenter?
Yeah. So like
To drop a bit of jargon, I'm sorry.
yeah, no, you're good. I didn't know the actual technical term for it, so I just think of it as like where the center of, because like you said earlier, like planets are kind of pulling on each other.
Right.
And most people probably think that the center of the solar system is the sun, when it's actually, since there's so many different planets and massive objects orbiting the sun, that they're also pulling on the sun, so that there's the gravitational center is not right in the middle of the sun. So
which is a good thing for us astronomers,
right.
because this effect makes it possible that we find planets in other solar systems.
Right. Yeah.
Can you explain how so?
So, I mean, there are several methods in how to find exoplanets. Most people think that we just see them in telescopes, which is hardly ever the case. We only see the biggest ones and the ones which are very far away from their sun, because stars are extremely bright and planets are very faint. They only reflect a fraction of their star's light. So what we do instead is we look for indirect methods. And one of them is we check for the wiggling of the star. So as we just said, the planets pull on their parent star, causing it to wiggle left and right, back and forth. And this can be seen, so either via astrometry, so we measure the very exact position of the star in the sky and do this over a long time, and if the stars wiggle back and forth, then there's something pulling at it. Or we can also look at its light, so the spectrum. If you can see that the star is getting closer to us, so a bit blue shifted, sorry. And then soon after, it moves away from us, so it gets redshifted, and this is periodically, then there is something again pulling at it.
Wow.
Something we don't see. And by how strong this effect is, we can also determine how massive the object has to be, which is pulling at it. And by how quickly this is happening, we can determine the orbit. So we can see how far away it is from the stars. It's pretty amazing. By just one measurement, you can make so many determinations about an invisible object.
That is insane.
Yeah. That's so cool.
And I think it's kind of misleading because, like, a lot of these, we'll discover a new exoplanet. Like, for instance, was it Alpha Centauri that we discovered a bunch that were, like, actually in the habitable zone and were, like, approximately the size of Earth?
Proxima Centauri, there was one.
Proxima Centauri.
5 years ago.
Right.
Like this.
And they made a pretty big deal. I think it was, what, 7 planets?
No, that would be TRAPPIST-1. What do you mean?
TRAPPIST. Okay, yeah, it was TRAPPIST-1. That's it. It was 7 planets where like they thought that they were all like pretty close to the size of Earth, and a couple of them were in the habitable zone.
Yeah.
But like it, and like that's all we know about them. But you have like these artists that come out with these like crazy looking like visualizations of the planet, and it's kind of misleading because then we just assume like, oh, we can see that with a telescope, and it's like, no, we can't see that with a telescope.
This is very tricky. Thanks for bringing this up. We in the communication, as the communication people, we always are aware of this issue. So whenever possible, we try to show real observations, because this is, I mean, it's always better to show the real thing. But especially when it comes to exoplanets, in the best case, you can see a tiny dot next to a bright dot.
Right.
And most of the time, you don't see anything, I mean, just wiggling lines in the plot. This is nothing which makes the headline of any newspaper. It's just not how news work.
Yeah.
So we have to come up with these beautiful illustrations. And I've been lucky. I've been working with 2 very, very talented people who actually made some of these amazing TRAPPIST illustrations. And we always try to make it very, very clear in the text, in the title, that this is an artist illustration. And still, so many people, even though it's in bold, fat letters, it's artist illustration of TRAPPIST-1, think it's the real thing. And I think there's nothing you can do about it. That's
I think it's just, I mean, because that's what people want, though. They want that flashy picture, like, and that's a lot of people. I feel like will just like read the headline and see the picture, and they're like, oh yeah, we discovered. It's like the whole thing with like a lot of people like. We discovered phosphine on Venus, and some people were like, oh, we discovered life on Venus. And it's like, no, that's not what happened. We just discovered phosphine, which is a molecule. So Similar when we find exoplanets that we think could be in the habitable zone or could possibly harbor the potential for life. We like show them artist illustration, and then we're like,
And I think that false color images and stuff like that are a good sort of um, balance between taking an observation that's actually scientifically accurate or scientifically relevant, and then making it beautiful so that it's more palatable for people who are unaware of the scientific field. So, like, that was just something like I saw the cyclone image that NASA released on
oh yeah,
Jupiter,
it was
right?
of the
And
North
it's like
Pole.
very beautiful. It's all these like really crazy colors, and it's nice texturally. So it's very palatable for people who don't necessarily deal with
No,
science all the time.
right? Yeah,
Right.
definitely.
Is that
so
something that you deal with a lot in scientific communication? Like, is that
Yes.
discussion that you have?
Yeah, again, it's very tricky. So we have to work on the images before we release them. I mean, even as an astronomer, you work on the images before you do science with them. But this is a very complicated process, and nothing you repeat over and over in every text you send out. So you have to work on these images to make them this beautiful. And then when we add images from different wavelengths and color them according to very strict guidelines, so there is really a very strict code, which of course you can circumvent under certain circumstances, but normally you have to really apply to the Hubble palette, as it's called, where you really have assigned colors for each individual filter set. It's very tricky to communicate this to the public, that what you see here are not the real colors. And the problem starts that most people are not even aware how the colors in their own cell phone images appear. All people think, or many people think, there are people out there who know better, but many people think that their cameras actually take these beautiful images they see on their display, when it's far from true. In the end, I have this discussion very often on my Instagram channel when people call, yeah, this is all fake and these are composite images, and I tell them, well, your profile pic is also a composite image. You're just not aware of it. Your camera takes 3 different images, which are all grayscale. They don't contain any color. But the computer in your cell combines 3 different images and colors them and enhances them and color balances them. And then you see it on your display as what you took. But it's not what your camera sees. The astronomer makes it a bit more complicated, a bit better, and a bit more efficient in a way of the data that comes in. But it's the same process your computer does in your cell phone. So I think the problem really starts there, that people use a technology like a CCD camera in their cell phone, which originally comes from astronomy, and don't really understand it. They just use it a million times a day to take pictures of their food, but they have no idea how it works.
Yeah.
Yeah.
Food eats first, right? Or phone eats
Phone
first.
eats
That's what it
first.
is. Yeah, everybody takes a picture of their food.
So, in that same vein, going back to when the image of the black hole was sort of created through all these data points, what are your thoughts on that? Because that's not even really something that we observed with cameras per se. It was just all these sort of data points from sensors and like electromagnetism. And
right.
so, like, what are your thoughts on taking data like that and then converting it to an image that people can relate to?
It's a bit more difficult. Again, I'm repeating myself. Sorry, I sound like a broken record.
No, you're good.
The black hole image in particular is, of course, if you have interferometry, is where you combine data from different instruments which don't really work together in the first place, but you combine the data to increase the output. It's still real data, what you see in the end, but it's of course not what the individual telescope sees. The black hole image was even more trickier because it contained so much different information over a long period of time, and it wasn't really clear of what the image should look like in the end. So that was a bit of a back and forward process.
Right.
The idea was like, this is how a black hole should like as we expected, and then we look in the data if the data is reproducing what we expected to see. And they did this with 4 different teams, which really work completely differently with different data sets, with different algorithms. And luckily, in the end, each team found out like, yeah, it looks completely identical, no matter which algorithm you use and which method you take. It always comes out to the same image with tiny variations, but not changing the physics or the overall appearance. But of course, it's more than just a picture of a phone. We were thinking of addressing this when we worked on the press release. I was lucky. I got my hands off because it was massive. It was really massive and messy. I mean, the whole process took 2 years from we have the image to we send it out to the public.
Wow.
Wow.
That is wild.
Yeah. That was really wild, and there were way too many people involved, but it was really worth all the work, and it was so amazing when I finally could tell people after 2 years what I've known since 2 years. I'm really bad at keeping secrets. So that was a tricky discussion, and I think I would have to read the press release again, but I think it's mentioned somewhere how the image was made and that it's not just a click and there it is observation.
Right.
But
It's not
I
like
really
taking a
would have
picture
to
with
check
your
it
phone.
again.
Yeah.
Right.
Wow. So I know we just kind of jumped into the science stuff. How did you first get into astronomy? Like where did you go to college for astronomy, or did you just kind of was it just kind of a side gig that you really liked and just kind of picked up on as you went? Or
Well, it all started with a TV series you most likely never heard of. It's called Star Trek.
Definitely heard of Star Trek.
Yeah. So both the old one and the next generation, and I got just fascinated really what's out there and trying to fly to these places and be completely somewhere else. So in high school, I was already interested in astronomy, reading all these popular astronomy books which were available. And then I started to study astronomy. So in Austria, where I'm coming from, it's one of the few countries in the world where you can actually study astronomy from start. So you don't have to go physics, you can go directly to astronomy.
Really? That's awesome.
Yeah, must be nice.
The first couple semesters is basically you have to do all the physics courses plus astronomy on top. So it's not a big win. But later in the classes, then you really can focus on specific astronomy stuff, really on planet formation, galaxy formation, evolution, cosmology, really what you want. So the University of Vienna has really great curriculum there. I did my bachelor and my master's there, and for my PhD, I moved to Heidelberg in Germany. Heidelberg is an amazing city, very beautiful, and it has 5 astronomical institutions.
Wow.
3 from the university and 2 Max Planck societies. I went to one on top of the hill. So if you ever come to Heidelberg, there are 2 woody hills, and on one you can find an old observatory, and right next to it, the Max Planck Institute for Astronomy. And there I did my PhD in the evolution of galaxies in the last couple of billion years. So I tried to find out how their color changed. Super boring for outside people. And during my PhD, I discovered 2 things. Science is hard, really hard.
Yeah.
And I hate it.
And you hate it?
Yeah. And you work for weeks and months on a problem, and then you think you have solved it, and then you show it to somebody else, and they just look at your code and say, hey, there in the second line, you made a mistake. You can't do it like this. It's all wrong. And then you start from scratch again. And you do this over and over again. And after 3 years, if you did it long enough, you get a PhD. And I was thinking, if this is the rest of my life, please shoot me. No way I'm going through this nightmare all over again. So I was lucky that during my time at the institute, there was a construction site right next door where they built an outreach facility for astronomy. It's called the Haus der Astronomie, so literal translation, a House of Astronomy. It's a center for astronomy where educators from all Germany can come and get training on how to teach astronomy in schools. There's a planetarium, it's a visitor center where interested people can come and get tours on astronomy. And the director of the institute gave me the possibility to first give guided tours, and then to train other tour guides, then to write a tour script, guidelines on how to do tours. And at the end of my PhD, I volunteered or basically begged to do a planetarium presentation. So I created a planetarium show. Very terrible one, please don't watch it. It's from today's standard, I wouldn't do it again. But with my experience back then, it was quite okay. And it was a lot of fun. And I decided, well, this is something I want to do. I want to talk about science. I want to inspire people. And till today, I think it's the best way to communicate science is to talk to people directly, to guide them through an amazing place, show them what science is being done, show them pretty images, bring them into the labs, show them where the science is really happening, and not somewhere on Instagram where you see a nice image, but really on the place. Yeah, this is how my science communication career started. And again, I was lucky a bit later on. I got an internship with the European Southern Observatory. It's the biggest ground-based observatory in Europe. Well, the observatories are in Chile, but the organization is European. And I did a 6-month internship there. Very, very fascinating one. And again, I was lucky that during my time, another facility was constructed right next door, the ESA Supernova. It's a planetarium and visitor center. And then it was 2015. I had, or 14, 15. I had 2 lucky calls. The first one was that the public information officer of the European part of the Hubble Space Telescope retired. So she said she's moving on. But she asked me if I wanted to do the job. I said, yeah, that sounds amazing. I have 6 months of experience as an intern. I definitely can handle Hubble. And on top, the guy who was producing the exhibition in this new astronomy center wanted to have an astronomical consultant. And he asked me like, hey, you have 6 months of experience in an outreach department. You can definitely do a 2,400 square meter exhibition space, can't you? I said, sure, why not?
Yeah.
Yeah, so I had no idea about running an outreach business for a big space telescope. I had no idea about exhibition planning, and I did both. And it was an amazing time. I haven't seen my family a lot in these years, but it was worth it. Not from not seeing the family part, but from the experience and the people I was able to work with. And in the end, we have a beautiful, beautiful building in Munich, which is open to the public for free, 5 days a week. An amazing exhibition, amazing planetarium, amazing people working there. So if you ever come to Munich, don't go to the city center, take the U-Bahn all the way out to the to Garching, where the science campus is. Go there, have a full day. It's really worth it.
That's where I'm going.
Yeah.
If I go to Munich, that's where I'm going.
Fantastic years.
That sounds wonderful.
Yeah. So now you work for EMBL, and you said their mission is to I guess explain life, right?
Yeah, very simple.
More or less. So talk about that transition. How did you go from studying space, astronomy, observatories to, all right, our focus is life from a biological standpoint?
So there are several reasons. One is very simple, money. They pay very well.
Right.
Makes sense.
The other one is I've been at the end very well known in the astronomical community. Everybody was looking what ESA is doing and how Hubble is doing things. So it was very hard for me to really learn something completely new. So the astronomical community is very close to each other, which is good, but it also means that we all do things very, very similar.
Right.
And I had no idea how biologists work if they do things differently. So when I saw this job offer, which is also nearby, so if you have a family, then all of a sudden moving around the globe is no longer a thing. You look for jobs nearby. I was like, well, give it a shot. Of course, during the interview, I was asked, like, you have no experience in biology. How can you communicate about it? And I told them right away, well, if I can understand what the scientists are doing, then everyone can understand it. If I don't get it, then it's too complicated for the public.
Wow.
And this was
that's a great
kind of
answer.
That's a great answer.
That was kind of a selling argument, it seems, because just a couple of weeks later, I got a call like, hey, when can you start? So, and since then, I try to communicate how awesome EMBL is and what we do, which is very, very tricky because Hubble is kind of, you have one telescope, it has one mission, explore space.
Right.
And now I have EMBL. We have 1,500 people in 6 sites, and they have 80 different group leaders, so 80. And each group leader does something completely different as long as it's associated with life sciences, which is a very, very broad field. This is diseases, virus, cell functionality, RNA, DNA, computational life sciences. It really does everything we do. So it's really hard to summarize what EMBL is doing in a sentence compared to Hubble, which is exploring the universe.
So do you ever kind of mix those two subjects together and kind of try to figure out, like, if, let's say if life existed, like a very simple life existed on Venus, in the clouds of Venus, like, do you kind of mix those two together, and would you, like, basically like explain how life would exist on Venus, and do you have like theories on like how it would and where it would exist and like that kind of stuff, or like, or even on other planets?
Nothing EMBL is doing, because it's it's too far away from Earth in the end. When we look for alien life, of course, we always focus on life which is based on carbon and which is needing oxygen for survival. But now the discovery on Venus showed us, well, probably we should look beyond these borders and look for life which can exist without oxygen, or life which is not based on carbon, on silicon, for example. But this is way beyond what EMBL is doing. It would be cool to add a couple of group leaders doing this. I would be full supporting this, but I doubt that it would fit the EMBL mission, which is really focusing on understanding life on Earth, which is already complicated enough.
Right, yeah.
But for this, we have in astronomy, we have dedicated people doing astrobiology. So we really have people who try to understand astronomy and physics and biology at once. It's a really crazy people in a way that they understand three subjects well enough to mingle them together and to make sense out of it. I mean, it's hard enough to understand astronomy or physics on its own, and there are people who make 3 degrees and do basic research on things we have no clue about because we haven't found it yet.
Wow. That's wild. Yeah, I can't even imagine having to maintain like a knowledge base on all 3 of those different topics just to kind of like formulate discussion and theories and like all that kind of stuff. What about this is just a curiosity point. What do you think about like is it Enceladus? The moon? Is it Jupiter's moon? It's like covered in ice, but we think that there are oceans underneath the ice that's heated by the core of the moon.
So Enceladus is Saturn and Europa is Jupiter, and both have the possibility that there is a salt water ocean under the ice crust. We don't know yet for sure. Right. For Europa, we have some indications because there are water vapors sometimes coming out of the ice crust. Was also observed by Hubble. And now NASA and ESA both work together, and they're working on JUICE. That's the Jupiter Icy Moon mission. I forgot one of the letters, but basically it's a probe which is going to fly to the Galilean moons of Jupiter, so the big 4 moons, and investigate them. And among them is a mission to Europa in particular. And the hope is that they can plan the mission in a way that the probe is flying through one of these water vapors and collecting samples. Oh, wow. And then we can learn about the water, the liquid water, which is underneath the ice crust. And of course, the wild dream is that when you sample this water, that you can find some tiny fish in there, or probably just some bacteria, or like another form like phosphine. But that would be amazing, because then we can really make an indicated mission to try to drill through the ice of Europa and see what's underneath there.
That would be wild. What's crazy to me is how the water is heated under the surface. It's from the gravitational friction from its orbit around Jupiter.
It's just getting pulled and pushed and it's kept liquid this way.
That's insane. That just blows my mind. But so I look into this stuff constantly. So
it was like when Neil deGrasse Tyson was talking about how microwaves work. And they like cook with friction.
Right.
Yeah. It's like that. Just like,
You're just like, oh, okay.
It makes sense.
Yeah.
But it's just like mind blowing the first time you hear it.
Yeah.
So off topic. What are your thoughts on colonizing Mars?
Oh.
Ooh, that's a big jump.
That's
I know. That's why I said it.
I'm all for it.
Yeah, I want to talk about that. I want to talk about Starlink at some point, if you've heard of that.
Starlink.
Okay. So let's start with a less problematic one. Colonizing Mars, a wild dream. I love it.
Less problem.
I really love it. It's I would sign up right away. My partner would kill me before I even have a chance to get to the launch pad. But that being said, it's a wild dream, and this is something I really love Elon Musk for. I mean, he's a businessman. He's making a shitload of money, but he has dreams, and he's charismatic. And of course, in the end, it's about making money. But having this wild dream, saying, okay, let's bring people to Mars, establish a colony there, make us an interplanetary civilization. That dream is so wild and out of the earth, literally, that you just have to love it. I mean, just the possibility that we could do this and that we have the resources and the technology and at least one person who wants to bring us there. That's amazing. In the end, it's a bit like JFK, who told us we will go to the moon by the end of the decade, and that's the status. We will do this because we can do it. And in a way, Elon Musk is here the same. I mean, going to the moon for a camping trip of 3 days and coming back is a completely different thing than sending 100 people on a complete hostile planet and say, make your living there, you won't come back because you die there in one way or the other. But if you look beyond this wild idea, you also have to be very, very realistic. We have no idea how life in a low-G environment like on Mars works. We have no idea how to protect people lifelong from cosmic radiation. We have no idea how to harvest on Mars, how to ever make it a living planet. We have no idea how pregnancy works on Mars.
That's what I was just thinking. I was like, how would that...
If kids can actually survive on Mars, if a mother can survive there. I mean, we haven't, at least on paper, we haven't tested sex sincerity yet. I doubt it's true, but by official records, there's no information. And come on, if you're in the International Space Station and you're single and you have a female astronaut who is also single and willing,
you want to be the first one.
Do?
Yeah,
I would.
I'd try it out. Jeez, that's insane. I mean, yeah, because you're right. I mean, there's so many things that like we can theorize and we can do the math and we can all we want, but until we get there, we just don't know.
Well, I mean, toilets were a huge challenge for the International Space Station.
Yeah, that's true.
They are still. They just recently got a new one. At least I saw a post from CSA, from the Canadian Space Agency. Yeah, it's awesome. Space toilets are really amazing.
yeah, space toilets.
Space toilets. So complicated.
So imagine, I guess Mars toilets might be easier because you'd have a little bit more gravity to work with.
Some gravity, yeah. Isn't the idea though to live in the volcanic tunnels?
Yes, this would be a possibility, but again, we have no idea how stable they are, if you can really work in them. This will all take time. Can you make kind of construction material out of the material you find on Mars? We try this now with lunar dust. So ESA has a mission which they try to find out if lunar regolith, with this basically just this dusty stuff, if they can press it together to make bricks, to build houses, normal brick houses, of course, shelters in the end. But this turns out is super, super tricky. Nobody has ever done it before. But of course, it would make things much easier if you just bring a brick machine like 5,000 years ago to the moon to build a house on the moon.
Right.
Mainly for radiation shelter. And the same thing would be needed for Mars. We have to find out if you can build with the stuff on Mars. I mean, you cannot bring every single screw all the way from Earth to Mars for generations.
Yeah, it's too much weight, and that's we do have those 3D printers. Have you seen those that will actually like print a house, like a small concrete house?
I haven't seen ones that'll print a house.
Dude, it's crazy. I mean, it's pretty big. It's a big 3D printer.
It's so you're not talking about a Lego house.
Right. No.
Lego house.
Yeah. No. No, it's not a Lego house.
The solution.
It's like it sits in like the middle, and it's got this arm that swings out, and it just like basically draws a circle around itself that ends up building it up into a house. It's pretty cool.
That's pretty neat.
It's really interesting to watch. It'll build it in less than 24 hours.
Wow.
Oh, that's insane.
Yeah, it's really crazy, and it only costs like the materials and everything are like $20,000.
But
for
why
all
waste
of it.
money on that when you can just bring Legos?
Yeah, just make some titanium Legos.
You know, I'm writing NASA a letter.
No, you better send it to Elon Musk. I don't think NASA's going to Mars anytime soon.
I figured it out.
Yep, you got it. What'd you switch drinks? What do you got now?
Water.
Oh,
sorry.
No, you're good. You're good. I was just curious.
We thought it was something more exciting.
Thought you might have
Or
switched
just
to
a full glass of vodka. That could also be.
that's what I was like, maybe he's getting vodka now. So what are your thoughts on what we just sent to Mars? What was it? It's another rover. What was it called?
I don't remember.
Oh,
You're the one that knows all the names.
NASA just sent it. It was I can't remember. One of my buddies went and saw the takeoff, the launch for it. It's got that little
I
drone.
don't remember the name either. It was a very, very weird name, hard to pronounce for
it was kind of strange. But it's
I
got
haven't
that
followed
drone.
the mission. I haven't followed the mission, to be honest. But what you just mentioned, I followed that there will be a drone, a helicopter on Mars.
Isn't that crazy?
This is just another set of these nut ideas, which are just amazing. I mean, if this is working out, this is just a huge improvement. I mean, basically, the thing can cover an area as big as the usual rover do over years in just a day. It hops around and then flies.
And
over
doesn't
to
it?
the next spot.
It's charged solar. It uses solar panels, right?
Imagine it would have to be.
Yeah, that's insane. I'm really curious to see how well it works because, again, it's like, we can do all the math and figure out everything, but like until that thing starts flying on Mars, we don't know how the atmosphere there is. It's like a helicopter there, like the physics behind it. It's gonna have to be completely
like the
different.
aerodynamics.
Yeah, the aerodynamics and like how it actually works, the lift behind it is gonna.
And it has to fly on its own.
Exactly. That's crazy.
That's a huge AI problem.
Yeah.
Even. Jeez.
Oh man, there's just so much to that problem, and like everybody's like, let's just go to Mars, and you're like, it doesn't work that way.
I love how interdisciplinary the problem has to be. Like you're pulling in mechanical engineers, you're pulling in computer scientists, you're pulling in like life science people for agriculture, and
it's like a full like 360-degree problem. Everybody, you need like every engineer possible to like accomplish this.
It's like what he was saying. It taps back into that spirit of like 1969 of we're going to the moon.
Yeah.
Yeah.
So Mars to me is like.
So we mentioned earlier Starlink, and you said it was more problematic. So let's hear about that.
I hate Elon Musk. Did I say that I love him and I find him a very charismatic guy? That was all a lie. At least when it comes to Starlink. Starlink is a huge issue, at least for astronomers, but also for our culture. I really respect his idea. Again, it's all about making money, but I really respect his idea that he has to stream that everybody in the world should have access to the internet. It's the library, it's the form of information storage we have these days, and it's an amazing one. And it's just fair that everybody in the world should have access to it. But the price is very, very high. So the European Southern Observatory recently made a study on the impact of Starlink and the other mega constellations. So Starlink isn't the only constellation which is currently in production. There are several others. And they studied on how many satellites will be visible at any time in the night sky and how many will affect observations. So late in the night, you hardly can see any satellites because they're all in the shadow of Earth. But during dusk and dawn areas, when they're still lit by the sun, especially the solar panels they are powered with, they can be extremely bright. And these times are also important for astronomical observations. And it turned out while the ESO observatories in Chile are hardly affected because most of the observatories ESO has in operation at the moment have a very, very tiny field of view. So the chance that you catch a satellite in it is very small. But there are other telescopes out there currently under construction, like the Vera Rubin Observatory, which has a huge field of view. It's manned as a survey observatory, so it should cover the whole night sky every couple of nights.
Wow.
And 50% of all the observations of these telescopes will be lost because it's ruined by telescopes. And this is a big problem. I mean, in the end, you invest about €1 billion or $1 billion, doesn't matter in this scales anymore. And you have to throw away half of the data you collect because it's ruined by satellites. This is one thing. And the other thing is, of course, the beauty of the night sky and the stars above us has inspired generations of people, basically since ancient time. If you look at the disk of Nebra, which is basically the oldest replica of the night sky we have, we see that people have been inspired by the night sky, by these objects above us since 10,000 of years, 100,000 of years probably. And now we ruin this site completely by satellites. It's already ruined by the lights we have on Earth.
Right.
Light pollution is a big issue in cities.
Problem.
And now we put the cherry on the cake and say, oh, that's not enough. Even the people who can still see the night sky, they have to guess what's the star and what's a satellite in the future. Because when all the satellite constellations are in place, you will be able to see up to 100 satellites at any moment in sky.
Good Lord.
Wow.
That's
compared to a couple of thousand stars. I mean, still there are more stars, but the satellites will be very bright and very, very dominant.
Right. He's wanting to put like 40,000 or something like that?
At least 10,000 and 40,000, yeah. And then you have at least 3 mega constellations. So do the math.
And he recently, even I think just like a week ago, he launched 60 of them.
Well, yeah,
So, I mean,
their goal's been
it's
to
a normal
watch,
launch, yeah.
Yeah, they've been launching like 60 every 2 weeks.
Yeah.
For a while.
Yeah. It's crazy.
It's absolutely wild. They're already doing the beta test for Starlink.
For the actual,
the
actual internet part of it.
So the good thing is about SpaceX and Elon Musk is this press release became very, very public, and it was bad press. And it could either be that he wanted to damage reputation, stopping from his reputation being damaged, or because he's really caring. But SpaceX was contacting ESO and other ground-based observatories and say, okay, let's sit together and try to find a solution. Is there a way that we can darken the satellites in a way that they're no longer affecting the night sky for astronomers and lay people? I'm not sure where the discussion is at the moment. I'm no longer in astronomy. This is only what I know from the outside. But I think it's great that at least there is discussion and probably also a solution at some point. Of course, at the moment, as you said, there are satellites being launched all the time.
Constantly.
So it's increasing the problem. But these satellites are all in low Earth orbit, so they are deorbiting in a couple of years anyway. So if you say you start at 1, 2, 3 years probably with a new generation of satellites which are black, however they manage this, currently it's not possible. And they don't shine bright in the night sky, then at least in half a decade the problem is solved again. We'll see.
Yeah, because when you mentioned the problem with observatories and Hubble, the first thing that I thought of was like, okay, is there some AI solution where you can algorithmically control the constellation so that it's out of the view of the data that you're collecting?
Right.
Now that's a very complex problem.
Very complex problem. Yeah.
And it doesn't solve the problem for lay people, like you said, where you're just like looking at stars.
You can do it up to a certain point, and I mean it's already done now with airplanes, for example. So there are at big observatories you have contacts to air control or even secondary telescopes checking for incoming airplanes, and then you turn off the observation for the time the airplane is crossing your field of view, and then you start observation again to stop inflicting the airplane your observation. But you can do this with a couple of airplanes, but not with 1,000 satellites.
Right.
You can, of course, say this area is free for a certain time, definitely of satellites, but this is not how well-planned observation works. I mean, already now we have to take into account when an object is visible above the horizon, when is the weather good at a certain time. I mean, it could be that your most favorite target is completely clouded while the other side of the sky is completely free. Then you have to switch to your target B. And out of a sudden, target B is no longer possible as well because there are a lot of satellites. Now you have to switch to target C. That's not feasible in a real observation scenario.
There's just so much going on. Like, what do you think? Or what is Hubble's orbit? How? What is it?
Mm.
How high up is it?
550 around at the moment.
Okay, so it's higher than the International Space Station.
Yeah,
Okay. Wow.
luckily.
Yeah. Well, I've heard that this just recently they like barely missed some space junk.
The
They-
ISS, yeah, they had to make evasive maneuvers, and the crew had to go into the Russian area, which is on the far back, and where also the Soyuz capsule is for emergency exits, and basically sits there and hope for the best. It's a
God,
bit
that's
weird that we're in
terrifying.
21st century, and all you can do is you hide in the back of your car and hope that you survive the crash.
Wow.
Oh my gosh, that is terrifying. They said this.
So-
That's the third one this year that they've had to avoid.
Yeah, and
So-
it will get worse.
Another like off-topic big leap.
Oh, here we go.
So you said the ISS was in Russian territory. So what are your thoughts on Space Force?
Oh, this is a
the
big
the
leap.
TV series, or what a certain president is doing.
a certain president. I love it.
We can say it.
we could say his
We can
name.
say that Trump is doing it. No,
Yeah.
the real thing, not the TV series.
The TV series is quite nice though.
Have you watched it? I haven't seen it yet. Is it good?
Yeah, it's pretty good. I love the political aspects because it's referring to an president which is never called by name, but which is very clearly an acting president.
I'll have to watch. I gotta watch it now. Oh, that's funny.
Don't worry, we're aware of it. Like
Okay,
Americans.
yeah. So Space Force, well, it's completely out of my territory. It's military. It makes sense from a certain point of view. Of course, not as the press communicated it, or even probably the White House communicated it. It's basically, what's going on in outer space. It's from ballistic missiles which are coming in from outer space. That's not alien attacks, but the normal ballistic missile leaves the atmosphere.
Right.
To satellites, to surveillance projects. I mean, there's a lot of going on in military, so it makes completely sense to have a separate unit doing this. Calling it Space Force is probably a bit of an
excessive.
overkill. Yeah, it creates a picture, and there's a picture of Star Wars uniforms and big Star Destroyers floating around, which is of course not rare.
Makes me think of the movie Spaceballs. If you've
Oh,
heard
yeah.
of this,
Of course.
That's a great one.
it's a great movie.
Speaking of Star Wars, are those like, is that an X-wing behind you or a Y-wing?
Yeah. I just talked to my boss today. I need a bigger office. I'm running out of ship space. I have 4 models in here.
What?
An X-wing, a Y-wing, an Imperial Star Destroyer, of course the Millennium Falcon, and the Tentative 4.
Awesome. That is awesome.
That's so cool.
So, I mean, you're just gonna jump right into it. What do you think? Like, what are your thoughts on like interstellar travel? Do you think that like humanity will ever reach another star, like ever?
I don't like the word ever.
Yeah, I guess it stretches pretty far. So
Yeah, exactly. If you look 100 years back, we started to build the first airplane. And now we fly over the weekend from London to New York because it's fun. We have space tourism coming up. If you would tell this to the Brothers Wright, like in 100 years, you can book a flight to the International Space Station, I would call you nuts. And then the same thing,
Yeah.
we have no idea what's going on in 100 years. Of course, by current physics, by our current technology, it's completely impossible. You can, with some possibilities, send a probe into the nearest star system, which will take decades. So the Starshot Project aims to send a probe to Alpha Centauri.
Oh, is there already a project for this?
Yes, it's a project. They have some money acquired. Stephen Hawking was supporting it a lot when he was still alive. The idea is that you have a solar sail, which is powered by lasers on Earth, and you send a micro probe, really tiny probe, not one, but millions, all the way to Proxima Centauri with 20% the speed of light.
Wow.
You would stop there. It's basically you rush through this system, take a couple of images, and that's it. That's the whole mission. You have to aim carefully. If you miss the system, you wasted a lot of money.
Yeah.
Wow.
And it's gonna take those images, and it's gonna take like at the speed of light. Alpha Centauri is
Well,
what, 4 light years away?
Yeah, and then 4 years later, you get the images.
You get the images. Wow, it would take 4
But
years.
I mean, after 20-year flight, you can also wait 4 more years for the
Yeah,
images.
I would wait 4 more years, but that's just wow. I didn't even know that we had a project for that. That's awesome.
That's pretty crazy.
Yeah, I don't even know. Like, that's crazy. So Alpha Centauri, is it a binary system or is it a single star?
It's a triple system, actually. It's
Oh, it has
Alpha
3
Centauri
stars.
A and B, and Proxima Centauri is also part of it, but it's so far out that sometimes it's not considered as part of the system. But actually, they are orbiting each other, so it's a triple system. And the
Wow.
planet we know of is orbiting Proxima Centauri. Well, there are actually 2 by now, I think. So there was one, which was the first big discovery 5 years ago.
Yeah.
Was in the habitable zone, and then I think 1 or 2 years ago they discovered a second one.
Wow, I did not know that was a triple system. Triple systems are pretty rare, aren't they? Or did we just?
No, not at all. It's actually kind of uncommon to be a single star like the sun is. So
Really?
most stars in the universe are multiple systems, because they're always formed in a cluster. You don't have a single star being formed. You always have a full cluster of stars, and they're gravitationally interacting with each other before they get separated and make their own life in the galaxy.
That's wild.
So yeah, it's actually a bit rare. And there are some hypotheses that the sun once had a twin sister, and we lost it over the course of the universe,
Wow.
which is kind of sad. Lost
That is
sister
kinda
somewhere in the Milky Way.
Wow. Do you think that having a single star solar system is more advantageous for complex life developing on a planet?
Oh, that's $1 million question, isn't it?
Yeah.
What is encouraging life to form? Is it the star, the single star? Is it a specific type of star? Is it the area in the Milky Way or in the galaxy? Is it having a moon? Is it having a Jupiter-like planet in the solar system? We have no idea. I mean, all these aspects definitely play a role, but are they all needed? And
Right.
only certain aspects are needed, and which aspects
to what degree?
Right. So one
Yeah.
thing is, to me, is that like if our star was like less massive, right? And it's something I actually posted about recently. The habitable zone would shrink. It would be smaller. So it would be closer to the sun, to the star. And if you were that close to the sun or to your home star, it could cause you the gravity that would be stronger and would cause you to possibly be in tidal lock, right? So then that would make complex life like almost impossible if you're tidal locked to your star.
Does it?
Yeah, I guess it's hard to say because the life as we know it, as we personally know it. Yeah.
Well, there are some scenarios where I'm not into astrobiology, even though it's super fascinating. But there are some thinking about if life could be possible in this twilight zone. So you have, of course, one side which is burned by the sun. You have one side which is completely being burned, being dark and frozen. And then you have this tiny area in the middle where you have this constant twilight. You would most likely have a constant strong wind, hot winds coming into the over to the cold side. But it could be possible that there is kind of this temperate area, 100 miles wide, something like this, where life could exist.
So then you just have a ring
just
of life around the planet.
Yeah.
Yeah.
God, that's weird.
That's cool to think about.
Yeah, that is really cool to think about.
We were talking about, I guess, relativity a little bit earlier. Talking about if you were several astronomical units away from the Earth and you had some really powerful mechanism where you could actually observe the Earth, or at least the light.
Well, not astronomical units, light years. Because it'd have to be light years.
You're right. Yeah, sorry. This is way outside of... This is Dylan's.
Yeah. So we were basically... I can take... we were talking about, like, if you're... Let's say if you, for some reason, are, like, at this really advanced civilization and you have really powerful telescopes, powerful enough to see the surface of the Earth, and you're, let's say, a few million light years away. I mean, that's, as physics and as we understand it, that's impossible. But, we're just
It's
apes.
hypothetical.
Yeah. So, but yeah, so hypothetically, you would be, depending on how far away you were, you could see the dinosaurs roaming the earth if you were to look at us from that far away. And I just thought and then I started thinking, I was like, well, what would you see and what would it look like if you were approaching Earth at the speed of light from that far away and like watching Earth
And observing it.
Are you observing like the history of the Earth kind of in fast forward at that point? Like that would just be, I don't really know how that would work, but it was an interesting question that came into my mind.
So basically you have a telescope the size of a solar system, which is moving close to the speed of light towards Earth.
Earth.
That's an
right.
interesting story. Yes. Really basically, weird. If you would manage to get real-time images, it's a very hypothetical scenario, but could make a nice science fiction story. Then you would see life evolving on Earth in kind of a fast forward from your point of view.
Like a time lapse.
You crash right into Earth with your sun-like telescope.
Right.
Yeah. And you kill everyone. The end.
Your galaxy-sized telescope.
Yeah. Golly, that would be so cool, though. Like, I mean, it's as far as we know, it's impossible. But I love
Go
ahead.
Actually, it isn't.
All right.
Well, not to that extreme that you can see over 60 million years individual dinosaurs hopping on another planet. But you can make city-sized areas visible on an exoplanet with the right technology. The idea was, it's a really wild idea, and again, we don't have the technology yet, is to have a probe very, very far away from the sun and use the sun as a gravitational lens. So the sun is basically acting as a magnification lens.
Right.
To look at an exoplanet. And for this, you don't need that big telescope. I don't have the numbers right now. I have wrote an article years ago about it. I could look it up. You have a probe very far out, still orbiting the sun, moving very, very fast, because otherwise you lose track of the planet right away again. And you use the sun as a magnification lens. And then in this case, if you manage to move fast enough to keep the planet in focus and the sun right in between you and the planet, which is light years away, then you could use the sun as a big lens and you would see a planet in such details that you could resolve objects down to kilometers in size. So
that is wild.
The physics is there. We only need a super rich guy with fake hair implants and a fable for rockets to build such a telescope.
Elon Musk, we're calling you out.
This is what you said.
I didn't say the fake hair implants part.
Hey, have you seen some of the pictures of him when he was at PayPal?
Yes.
Oof. I'll leave it at that.
He had a glow up.
He had a big glow up.
Yeah. Rocket science is really reviving your hair.
Yeah. It helped him out, that's for sure.
What are your thoughts on the golden record? So like sending
I love
out
the golden record. I think it's so cool.
Yeah. So we made the assumption that binary is the simplest language that we could send out. Do you think that's accurate? Do you think that there's any sort of probability that we would find some species which understands that and sends something back?
Do you know the Arecibo message going away from the golden record? So it was basically a binary code message being sent to a star cluster very, very far away via radio. And the idea was to have, of course, you have to arrange these messages, zeros and ones. And the idea was that whatever alien civilization is recording this, they have to arrange it in a correct way, in a correct format. And then you get the planets of the solar system, indicating that we are in the third one. You get that basically how we look like. You get a star chart with pulsars indicating our position in the Milky Way. You get some indications on the size of humans by resembling how big an atom is. So this is all in there. And they send it out in the hope that an alien civilization would be able to decipher it. And there were soon some doubts that anybody would be able to do it. So what the project owners did, they sent this code to astronomers and computer specialists all over the world without telling them what it is. It was basically you received an email or a
Really?
mail probably with just zeros and ones in a huge line.
Right.
Without any further information. And nobody was able to decipher it. There was one person who was thinking that, well, that's probably from the Arecibo Observatory, and was sending some zeros and ones back, which rightly arranged gave, I think, a flower or something like this. But nobody was able to decipher all this information which was hidden in this short message.
Wow.
And this was a human mind trying to communicate to another human. And now think about an alien civilization having a complete different background in how to communicate, even if it's in zeros and ones, which we have used as a basis in the first place anyway.
I mean, the probabilities.
They wouldn't be able to understand what we want to say to them. It's just
that gets into a whole other can of worms.
Yeah.
In my opinion. So if life evolved on another planet and it wasn't carbon based, would their consciousness be the same as ours? Like, would they even experience the laws of physics the same way that we do? You know, this is because their atomic gravity would be different. Their atomic structures would be different.
Yeah, they'd be
any brain
completely different
that they developed, if they had one, would be different. It's like, how could we even interface?
Yeah, I don't even think it's possible.
Right.
There are some good Star Trek episodes actually about this, also about silicon life forms. It's really, sometimes Star Trek has very good episodes. Some are really crap, to be honest, but some are really good. And it's basically to identify what is life in the first place. I mean, they're on the planet, if I remember correctly, picking up some stones because they're beautiful and take them with them. And in the end, it turns out that they are the babies of a living creature on that planet. And they didn't recognize them because they are silicon stones for them. But they're living beings. So this is where Star Trek makes the good stories.
Right.
And it could be for us as well. I mean, even if you find a way to drill through the hole, through the ice on Europa and dive through there, what gives us the brain power to understand what is life down there, what is life looking, which never has seen sunlight, which is developing on a completely different planet in a completely different environment,
dark and like freezing
completely
cold water.
dark. Yeah,
this makes me
no
think.
idea.
Do you think that we could even approach understanding that before we understand our own life?
That's a good question.
Yeah, that is a good question, because we really don't understand our own,
right?
As of right now.
I think it's very tempting. I think it's very tempting to say yes or no. Like, oh, well, obviously you can understand things without having some frame of reference, and then you cite some examples.
Right.
But then you also say no, like you could never understand it because you only have one frame of reference, but which is your own.
Right.
But I think it's like the answer is probably a lot more muddled than that.
Right.
Like we might be able to, we might not. Like, yeah, it's very tempting to say yes or no to that question.
And this is what I love about science fiction, is because he's like quoting like Star Trek.
Yeah.
And like, because like a lot of people, like, you pull up science fiction ideas of like a warp drive or
an iPad.
Or not, even like a cell phone, like that.
Or
kind
a
of
cell
stuff.
phone.
Yeah, I mean, these were all just these crazy ideas, but now like they're kind of coming to reality. I mean, it's like, I think you can actually look to science fiction for the next big discovery, or like some of them. Some of them are obviously outlandish. It's not like like Rick and Morty, where I can have a portal gun to jump between dimensions.
Maybe.
I mean, I can't say that that's impossible. I'm not going to say that that's impossible.
We were on the same page.
Yeah, I wasn't.
Why not?
I'm not going to take it that far and say that it's impossible. But some of them are a little too outlandish. Some of them you're like, oh well, maybe.
So
like the dimension where like there's like the chairs are made of people and there's pizza.
Sure.
And they're using like it. You know what I'm talking about? It's like weird episode, but
one of my favorite quotes. Basically, there was this theory that cats were actually the dominant life form of Earth.
Okay.
And that they're observing and learning from humans, like as an experiment, and just pretending to be dumb. And I can't remember who it was, but there was some scientist that said that theory is not crazy enough to be accurate.
That's hilarious.
Yeah.
Well, we all know from the Hitchhiker's Guide that the mice are the true owners of
Exactly.
Earth, and the dolphins are just here for a visit.
Yes.
Yep.
So long, but thanks for all the fish.
Exactly.
Yeah, I love that book.
Oh,
yeah.
man.
I think this is as good a time as any to wrap up. At the end of every episode, though, Matt, we give our guests a little bit of time to talk about something they're passionate about, talk about their work, maybe give some advice to our listeners.
Yeah. Send out a message to the world of like 100 people
that actually listen to us. So if you want to take that time, maybe think about some message to tell people. Yeah.
That's quite a message for the end. I think the most important message I have to bring out is be curious about the world you're in. I mean, this is what a scientist is doing every day. I had the pleasure to guide a lot of school classes around, and whenever I start a tour or a talk, I always ask them, what do you think a scientist is doing? And you get all these cool answers, all right. And in the end, I tell them, well, what a scientist is doing is they ask questions. They ask questions and try to find out how the world works. And every kid is the best scientist you can ever have. I have two in here. They're brilliant scientists, and they drive me nuts because they question everything. And in the end, it's a good thing because you have to think how things work and why things work. Nothing is for granted. And as a grown-up, you sometimes lose this spirit. It's just like, yeah, you get into a car and it drives, and you never question why it drives. It does. And I don't know, if a sudden you have a kid on your back seat and you get a question, why is a car driving? And you're like, I've learned at some point, but probably I should relearn it and try to understand it this time.
Right.
And this is what's driving humanity, is understanding things. And as long as we are curious as individuals, but also as a society, I think we're progressing. And this is where I really love Elon Musk, where he says, okay, we have to move forward, we have to improve things, we have to get better. And this is, of course, also in the sense of Star Trek. Probably Elon Musk is a big Star Trek fan as well. Try to become better in the sense that we try to understand the universe and also ourselves. And in this sense, I think I have the best jobs in the world because I was first exploring the universe, and now I can explore myself in the form of why the hell do I actually work as a human being on a macroscopic level.
Right.
That's so cool.
Yeah. Wow.
Well, thank you. That's great advice.
Yeah, that was awesome advice. I love that.
That was very long.
No, that was perfect.
That was perfect.
Yeah.
Well, thank you so much, Matt.
Yeah.
It's been a pleasure having you
Thank
on.
you. It has been a pleasure.
Yeah.
Yeah.
We'll definitely stay in touch.
Definitely.
We do follow-ups with guests all the time, and we'd love to have you back sometime.
Yeah, we'd absolutely love to have you back on the show at some point.
Yeah.
That would be great. It was great fun.
All right,
yeah.
Great.
Cool.
All right. Well, we'll see you. Have a good night.
Have a good one.
Bye.
All right.
See ya. Dude. He's cool.
He's a cool guy.
What a great guy.
That was so much fun.
Yeah. I love talking to him.
Yeah, I loved learning about space from both of you.
When I start talking to somebody else that knows too, I start pulling out things that I forgot that I knew. I'm like, oh yeah, what about this and this and that?
Dude, I was struggling.
I could tell. I was like talking about something. I'd look over at you and you're like,
duh.
You're like, oh.
This is so, it's so fascinating to me and I love it.
Right.
But I just don't know. It just makes me want to read more.
Right.
It just makes me want to learn more
So
about
you quit
space.
saying atomic units?
Yeah, God. Dude. Stop.
I'm just teasing.
No, I know. He corrected me too.
I know. I loved it. I was like, because I was like,
no, but that's great though. I think that's what so many people need is they need to know that like, okay, me and you, we don't know everything. Like Matt doesn't know everything. It's like what he was talking about.
I love that he talked about like, I kept using the word telescope.
Yeah,
exactly. I was trying to say
Definitely
microscope.
made me feel better.
Yeah.
But a scientist is somebody who doesn't know things. That's like our job description.
A scientist is somebody that accepts and loves the fact that they don't know things.
Exactly. And then like and then science itself is the process of going from that to knowing a little bit more.
Yeah.
Yeah. And that's such a beautiful thing. I think he captured that really well.
He really did.
Yeah.
Yeah, it was a great advice right there at the end.
So this has been Randoscience.
Yeah.
Thanks for listening.
Yeah, Randoscience signing off.